is ICP5 for knowledge discovery management. Lyle Vanfossan and Scott Brunton. So to start off with, the first things that we did were naturally loading up PySpark through the pip installation, collecting all of our imports from PySpark and other various libraries. For this application, one of the things that we did was we created this function here for collecting the top words from our data frames. Essentially, how this function works, we're gonna be using it for all of the different types of text data. So we have our standard text, our n-grams text, and also our lematized text as well. So how this function works is basically you feed it the words data that you've collected from your various sources. For ours, we just used 5 different paragraphs that we retrieved from Wikipedia's API. They were just various paragraphs that weren't necessarily related. One of them was about self-driving cars, George Washington, etc. But getting back to this function, the first thing that it does is that it retrieves hash values for each word. These hash values are going to be used to represent the words in the later context of the function. And then it takes the features column that was generated from that, and it flattens it out, and it gets the vector values for each of those words. And at this point, we reorder those words based on their vector value in descending order. And we create a new data frame, which is just all of these words from each of the paragraphs. And we want to only use the words that have a rank that is greater than or equal to 10. So essentially just the top 10 words from each of the different collections. And then from there, we sort those lists that were generated. Each column in this is going to be a list, and we sort those we just gather them into one list and then sort them, and then we gather the top 10 of that entire collection of words from there. So that's how we are going to go about getting our top words for the rest of this process.
So we followed a pretty similar process for each of the operations, whether it was text data limitizations or n-grams. So I'm just going to cover a high-level process. We can talk about the results after that. So first thing we did was we import our documents, read them in from our shared drive here, and we removed any special characters with a regular expression. And next thing, we created a data frame from our document, our array of documents. And after that, we then tokenized our data frame per word. And at that point, then had to hash it and prepare it for being used in our models. So created a vector.
Oh, sorry, Scott. One of the things that I just want to point out is because we used a much larger collection of text than what was provided originally, we had to increase the number of features. So I believe in the example it was 10, but we actually increased that to 1,000.
Mm-hmm. Okay. And then the next thing we had to do was take our vector and run it through the models provided. And after that, we are presenting our data after it's been ran through the models. And here's where we're using our top words function. And we're just passing in our data frame. It's returning a data frame, and it's displaying the top 10 results from it. And then, let's see. And then for those, we had to get the synonyms for our top words. So we copied them over from on our top words, we ran the find synonyms function on them, and get different results per process. You want to go over those, Lyle?
Yeah, thanks. So we're not going to really go over, because the process for actually like collecting the data frames and parsing out the words was similar. The only difference is for n-gram data, we actually got the n-grams of the various sentences. You can see here, whenever we actually display this data frame, we have like George Washington and then Washington February. It was just a two-piece n-gram for those. Again, similar process as above, collecting all of the different features, running them through the words to VEC, and getting our top words as well. So top words was done up here. And then whenever we went through the words and top words, we got a pretty similar outcome. Actually, the n-gram data didn't seem to make too much of a difference. However, the the words that it acknowledged as similar were a little bit different for each of them. So you can see here the different outcomes of that. And then finally, through lemmatized data, it was also the same. Here we're actually gathering the different lemmas for the text in each of the documents and running it through that same process again of creating the data frame, getting the feature data for all of that, printing the top words, and then running it through another data frame and getting our new similarities. So here you can see the different similarities and the different outcomes for the new words that we generated. So that pretty much sums all of it up. Scott, I'm not sure if you had anything else to add to that.
No, just about the results of our lematizations, that it was significantly different than the previous two.
Yep. And it seemed overall, it seemed like lemmatization was at least a little bit more accurate. For an example, we have the word country here, where we got Cuba, bicameral, which I'm not sure. I think that might have been from the self-driving cars data that we had. But the conclusion was that it seemed like lemmatizing this data made it at least a little bit more accurate in certain situations. But that is all for this demonstration. Thank you very much.